This is the continuation of our periodic table lesson. So far we have discussed group 1, group 2 and group 3A. So now let's start up with the remaining groups. If we are moving towards this group, this would be now 4A, this would be 5, this would be group 6, this would be group 7, this would be group 8. And I have already explained you that why helium is in group 8 despite it only has 2 valence electrons. Now let's talk about group 7. If we are considering group 7, then as the rule implies, any element that is placed in group 7 would have 7 valence electrons. So they have 7 valence electrons, 7 valence electrons. Then that means in order to become stable, they need to complete their octet, and as octet means 8, so they gain basically one more electron. Let's consider the electronic configuration of fluorine, for instance. Fluorine atomic number 9, so it has K 2 electrons, L 8. I'm sorry, L should be not 8, L should be 7. So if we are working with the same configuration, then K2 and L7. So it is very much evident that its last shell has 7 valence electrons. Second, it needs one more electron to complete its octet. So fluorine would gain one electron to become monovalent anion. As the name implies, when we are saying mono, that means one valent charge, anion means a negative charge. So if we are working with fluorine, so we can say fluorine will gain one electron to form fluoride anion, that is F negative. Say similar is the case with all the remaining elements of group 7, that is fluorine, chlorine, bromine, iodine and astatine. If we are moving towards group 6A, so then we can proceed up with the same logic that it would have 6 valence electrons. Then in order to become stable, they would be gaining 2 electrons. So they would form divalent anions. Let's consider, for example, oxygen atomic number 8. So K shell 2 electrons, L shell 6 electrons. So oxygen would gain 2 electrons to form oxide negative ion, that is divalent anion. Similar is the case with group 5A. So we can easily predict what happens in group 5. Since atomic basically, if we are working in group 5, so this can be easily predicted that they would have 5 valence electrons, and then in order to become stable, they need to have 3 more electrons added, so they would be becoming trivalent anions. Then if we look at the general representation of this periodic table, what we find is these elements here, they're metals, and then we have a staircase here like this. So the elements under this staircase, they are usually metals, and these, they usually are metalloids. Now what are metalloids? Metalloids are elements that share the properties of both metals and non-metals. And then the remaining elements, these, they are non-metals or they are all gases. So if non-metals or gases. So what can be said easily is, in moving from left to right in the periodic table, we generally move from metals, relatively more reactive, more unstable metals, to non-metals. And These elements that lie in between metals and non-metals, they are known as transition elements, and they are all basically metals. And in some courseworks, these elements, they are categorized in family B of the periodic table. So for our understanding, we can just ignore these numbers. So this is group 1, 2, 3, 4, 5, 6, 7, or 8. And if we have the same numbers here, 1, 2, 3, and so on, so they would be family B. So that was the reason. And we can also say these groups as group 1 or group 1A, group 2 or group 2A, group 3 or group 3A. So these can be group Bs, 1Bs, 2Bs, 3Bs, 4Bs, and so on. So that basically gives us a general idea about how to relate the element with the group, and how to generalize the concept of that element being having a cation, that element would be a cation or an anion.